Hello. Today is September 10th, 2010. I'm down here in my lab, and I thought what I'd do today is give a quick demonstration of a simple little shield I've made using the Amicus module. And essentially what we've done is I've taken Philips Universal Remote Control. I've made up some simple boards. I ordered these boards through Express PCB, making these boards, laying these boards out. It's very straightforward, very simple. It takes no more than about, this board was probably about 45 minutes or hour or so. Make two of them so I can, in the same order, I get 4 of these boards for a pretty reasonable price, at least for demonstration purposes. And then you can get them in quantities for, if I ordered 100 of these, I can get them for about $6 a board. They're two-sided boards. They do a fantastic job. I've always been very, very happy with them. Very easy to work with the software, very easy to customize anything you need. And these shields, I provide all the files for the Express PCB board layouts. I've populated the board here on this version, and I'll go through and kind of demonstrate what each piece is. So essentially what we're going to be doing is I'm going to be receiving any of the infrared signals from the Universal Remote Control through this receiver here. I have a little indicator right here that'll show me when it's actually receiving signals. You can see those 2 white chips there are opto-isolators. Essentially their purpose is to interface the 3.3 volt microcontroller to the AC world. So you're actually firing a little infrared diode in there that's going to be picked up on the other side by a phototransistor sensitive to that infrared diode. That will then switch on the triacs, which will turn on and control the flow of the AC. For the AC, I've built up a little to input it. I've got everything plugged in here to my little power strip. I've built a simple little box using a wall outlet and a little plastic box to keep from zapping myself. That powers right into the board. There's no fuses on this board. This is a simple demonstration. Whenever you're working with AC, you've got to be very careful. Very easy to kill yourself. Stop your heart by putting AC current through your heart. Doesn't take very much to stop it. Okay, and then I've got 2 little yellow indicators there that will indicate which of the AC circuits have been turned on, circuit number 1 or circuit number 2. All pretty straightforward. I've already decoded through a simple program that anybody could figure out in a very short period of time, reading the Philips remote control using the Amicus or the Proton commands. I know what any of these buttons, the microcontroller will be able to tell any of these buttons. So I have basically a case-select system in there that will tell me if I press the minus sign or the 0, anything. I've customized it for this specific remote control, which is $10 up at the local store. We've had this for years. I swiped it for my wife, and she doesn't know it's missing yet, so I'm still using it. Now you can see, first thing I'll do is I'll turn on the AC, and then for the load, for the AC load, I've just got a simple little overhead light here that I'm going to be switching on and switching off when it receives these codes. And the way I've programmed this remote is pretty straightforward. If I press number 1, you're going to see that it's going to, first of all, you're going to see the blue LED indicator flashing. You're going to see, it's hard with all the lighting that I have in this lab right now, but you can see if I shut this light off here, you can see that it's indicated that circuit number 1 is on, and you can see obviously that the light has come on. If I press the 0 button, it turns it back off. Any of the other button presses, I haven't coded all of them yet, so some of them work, some of them will not. If I press, for example, the volume, you'll see that it will indicate that it's receiving a signal, but there's nothing coded yet for it. Now obviously we could code this for whatever we need to. My end goal eventually is for home automation projects. This is very convenient when you're in the room. When you're outside of the room controlling in other areas of the home, I'll be using wireless modules, and I'll demonstrate these in future projects. I've already started working on the code for all of these. I've got the XB modules. These are actually working quite well right now. These are very easy to work with. Very quick development time for this. The microchip versions are about $20 cheaper, so I like that. Quite a bit harder to code for. But I've got some simple little boards right here that I've made that I can just snap the little modules in there. I've got one for a base unit and one for a remote unit, so I can be able to send information back and forth, but still working on these. I'm not ready for prime time yet, but just thought this will give you a quick little demonstration of a simple way to be able to control things in your house. And then yes, both circuits, if I press number 3 here on the remote, that actually turns on both both of those LEDs and both of those AC outlets, even though I only have one plugged in at this time, but this still gives you the basic concept. There's the unpopulated one, but we could easily populate that. Actually, I had it populated earlier. Alright, well, that's all we have for this one. I will post the code and the board layout files, and feel free to write with any questions you may have. Okay, goodbye.